So welcome back to Aayu Pathshala. Friends, today we are going to start with the network layer. Previously, we have seen the data link layer and the physical layer of the OSI model. So this is my channel, Aayu Pathshala. If you are new, kindly subscribe it. And the notes of the computer network, already we have uploaded some notes and that is available on this Telegram channel, t.me/apdcio2025. So join this channel and you can download the available notes on this. So we have already seen in the like computer network, the OSI model, there were seven layers, out of which the first one was the application layer, that is the layer number seven. If you are transmitting the data, the first layer encountered will be the application layer, then presentation layer, session layer, and transport layer, then the network layer, and the data link layer, and the physical layer. So we have completed the physical layer, we have seen the data link layer, and we have seen here that this layer is involved in framing, and there is a frame of bits, and this frame of bits actually have some header portion, then there is a payload, and then there is a CRC, and this frame was actually 46 by 2 1500 byte that we have already seen. So now this frame, that the payload that is added to the payload section of the frame, is being transmitted from network layer, and in the network layer that payload is known as the datagram. And obviously, this datagram is not generated at this layer. It is transported or like transmitted to it from the transport layer, where from the transport layer, it is known as the segment. So the transport layer, there is some combination of bits, as we have seen the bits in frame. Similar structure is there in this segment. There is a group of bits. These bits, like after some addition or deletion of bits are done in the form of header and footer, and then this entire segment is transported to, like, transmitted or handed over to the network layer for transmission. So this entire layer is known as the datagram in the network layer. So whenever we say that the datagram, it means we are at the network layer. So whenever we talk about frame, it means we are at the data link layer. So network layer, we have already understood the real world analogy where we have talked about the how a parcel is being delivered from one location to another location, and there we have talked about the logical addressing. So the very important function of network layer would be, number one would be logical addressing. Logical addressing. And here it is known as the Internet Protocol version 4 addressing and Internet Protocol version 6 addressing. So this logical addressing is done for the segment that it received. For example, it received this segment, it adds some header to it. It will add, then it will combine this header with payload, and the entire structure will known as the datagram, and then it will transmit this datagram. So entire this header, there will be addressing will be done, some other thing will be done. So this logical addressing is basically done by the network layer. So why logical addressing? We have seen that thing entirely when we have done the real world analogy of the OSI layer. The second would be like the second most important function. One is the logical addressing. The second is what is called as routing. Like, see, in the network layers, there are different devices, for example, and we have to reach to this device from P to A. So there could be like different connectivities to it, like this, this, and this. So routing has to be done. Either the packets could move from this device to this device to this device, from here to here, and finally reach to A. Or it would have the second part, that is, it may travel from this device to directly to this device and then reach to A. These are the two paths available. So under the routing functionality of the network layer, we will see there are different algorithms which decide which part to follow, and accordingly, based on that algorithm, the path will be followed. So another important layer function is the packet forwarding. So these three are the important roles of the network layer. Number one is the logical addressing, number two is the routing, and number three is the packet forwarding. That is forwarding the packet to the next node so that it could reach to the final node. For example, say when this packet is, let's say this is P1, this is P2, and this is P3. When a packet is forwarded from P1 to from P to P1, when it is forwarded from P to P1, how does P1 know that it does not belong to it? It's because it is the P1 knows its physical address, and also there is a logical address of P1, and the packet itself that is being transmitted from P to P1 contains the logical address. So it will see that whether there is the logical address matches with it. If it does not matches, it will forward the packet to P2, and ultimately it will deliver the packet to A, device A. And this is called the packet forwarding. So there are three important functions of the network layers. So let us first understand what is the Internet Protocol for frame, or we say packet. What is the structure of it? See, this here we have in this IPv4, we have a payload. Obviously, payload has been transmitted from the transport layer, and that payload, it can like that entire groups of bit, which we call a segment, will be fitted into the payload, and that payload will ranges from 20 bytes to 65 535 bytes. This is the range of the payload. This is the size of the payload. Then it has header. One is the payload, another is the header. Obviously, the size of header is also variable, and that is from 20 byte to 60 byte. Now, when I say that the size of the header is variable and it ranges from minimum 20 byte and maximum 40 byte, that is, there is a 40 byte variation. These 40 bytes comprises of option or padding that will be used as options or padding. So let us see what are the fixed header content of 20 byte. See, first of all, we have version that is of 4 bits. Then we have header length. Now, since header is variable of 20 byte to 60 byte, there must be some way to identify what is the actual length of the header. And for that, we have the field known as the header length, that is also 4 bits. So these two comprises of 1 byte. Okay, now next move to the service type. Next field is service type, and this is 8 bits. That means 1 byte. And out of 8 bit, the like 3 bits. This is the 3 bit 4, 5, 6, 7, 8. These 3 bits basically decides the priority. Like 1, 1, 1 will be the highest priority, and 0, 0, 0 will be the lowest priority. Then we have the other 4 bits as TTRC, and this is not used. So D is for delay, minimizing delay. P is for maximizing throughput. R is for maximum reliability. Just note it down. And C is for minimum cost. What is minimum cost? That is when we forward the packet between the in the network among devices, we need to calculate the minimum cost. If it is minimum cost is required, so we have to choose that part which will cost us the minimum. So these are the 3 fields we have seen, and the next field is like is known as total length, and that is also like 2 bytes, or we can say 16 bits. See, here we have the header length. Now also the total size is also variable, because the header length is also variable and payload is also variable from 20 bytes to 65,535 bytes. So we'll have a field total length that will represent the size of the total frame or the total packet, IP packet. Also remember friend, the header length, it is a 4 bit length. 4 bits है जो हम मैक्सिमम इसमें 1111 हो सकता है, जो कि रिप्रेजेंट करता है 15 को, लेकिन एक्चुअली में हेडर का लेंथ क्या है, 20 बाइट मिनिमम है और 60 बाइट मैक्सिमम। तो इसका मतलब ये हुआ कि अगर 15 हमारा मैक्सिमम हम 15 रिप्रेजेंट कर सकते हैं, तो हेडर लेंथ में जो भी बिट्स होगी उसको हमको एक्चुअली एक्चुअल लेंथ निकालने के लिए 4 से मल्टीप्लाई करना पड़ेगा। Okay, so if like the header length, this field is having data like 1011, that means it is nothing but 11. So the actual header length will be 11 into 4, that is 44 byte. Okay, this is with respect to the header length. So total length is now, it is of 16 bits, that is of 2 byte. Here we need not to multiply it 4. Only in the header length, to find the actual length, we need to multiply it by 4, not in the total length. Then other field is identification. This is also 2 byte. Then the next field is, just remember all this field. The next field is flag, which is of 3 bits. The next bit is fragmentation offset. So the 3-bit flag is like this one, D and M. D means the coming frame is not fragmented. It is not fragmented. And M means there are more fragments to come. अगर इस फील्ड की वैल्यू अगर 101, इसका मतलब क्या है कि फ्रेम जो है टोटल सिंगल फ्रेम है, देयर इज नो फ्रैगमेंट टू इट. और अगर 01 हुआ तो इसका मतलब ये है कि देयर आर मोर फ्रैगमेंट्स. ओके, सो देयर इज अ फ्रैगमेंट ऑफसेट. और फ्रैगमेंट ऑफसेट क्या बताता है कि हमारा जो भी फ्रेगमेंट्स होगा, ओके, तो फ्रेगमेंट ऑफसेट क्या बताता है कि हम जो हमारा जो डेटाग्राम है, डेटाग्राम को हम बेसिकली स्मॉल फ्रेगमेंट्स में ब्रेक करते हैं, तो इसके लिए हमारा फ्रेगमेंट ऑफसेट का फील्ड होता है. देन उसके बाद हमारा फील्ड होता है टाइम टू लिव. टाइम टू लिव क्या है? फॉर एग्जाम्पल अगर किसी नेटवर्क में बहुत सारे डिवाइस हैं और ऐसे ये पैकेट मूव कर रहा है, तो जितना बार ये पैकेट फॉरवर्ड होता है उतना बार टाइम टू लिव की एक एक वैल्यू डिक्रीज होती जाती है. तो कितना मैक्सिमम ये मूव करेगा नेटवर्क में? क्या ये इन्फानाइट टाइम के लिए नेटवर्क में मूव करता रहेगा अगर नहीं डिलीवर हुआ तो? नहीं. जब तक उसका टाइम टू लिव फील्ड एग्जिस्ट करता है, एक एक डिक्रीज करता जाता है वो. जैसे वो जीरो होता है उस पैकेट को हम डिस्कार्ड कर देते हैं. तो टाइम टू लिव विल बी लाइक 8 बिट्स और 1 बाइट. उसके बाद हमारे पास नेक्स्ट है प्रोटोकॉल. Protocol is also 1 byte. Then we have header checksum. Header checksum, and this is obviously 2 byte. Then we have the source IP address, and next is destination IP address. And how much this length? This length is 4 byte each. You might have heard na IP address like 192.201.101.23. This is like the IP address. So this is represented as 8 bits, 8 bits, 8 bits, 8 bits. Total 32 bits or 4 byte. So if we count in total, the total frame structure will be how much byte? 20 bytes. See, this is 1 byte. This is 1 byte. Total 2 byte, 4 byte to 6 byte, and this together is like 2 byte. This is 13 bit and this is 16 bits. Sorry, this is 3 bits and that is 13 bits. So total 16 bits, that is equal to 2 byte. 8 byte हो गया, 9 byte, 10, 12, और 12 plus 8, 20 bytes. So this is the 20 byte fixed header ka structure. And here we have to remember all this field, that is the version field, header field, service type, total length, identification, flag, fragmentation, time to live, protocol, header checksum, source and destination. So there is a mnemonic to remember this, which I understood as like my very handsome soldier took his identity flag, for time to live protocol. So V is for version, H is for header length, then S is for service, T is for, again we have here the total length. So T H took his total length, I for identity, F for flag, for means fragmentation, time to live, protocol, then we have header checksum and source IP address and destination IP address. This way you can remember the fields of the IPv4 packets. Okay, so when we talk about the IPv6 packet, just remember their source address and IP address is how much? 16 byte each. Source address and IP address is 16 byte each. And in IPv4, source address and destination address is how much? 4 byte. This is the difference. There are also some difference, but just remember the important difference between the length of the destination address and source address. That is, in IPv6 we have 16 byte, in an IPv4 we have 4 bytes. So this is the structure of the IPv4 packets. We have seen that the payload and this is the header. So the actual frame, if we see, or the actual datagram, if we see, datagram is what we have at the network layer. This will be header, and it will be around 20 to 60 byte, and then we have the payload, and this will be varying from 20 byte to 65,535 bytes. Okay. So we have seen the frame. Now let us move to the logical addressing. What is logical addressing? See, there are basically two categories of logical addressing. One is called the classful, and another is what known as the classless. So when we talk about the classful addressing, see, we know that the address is how much length? 4 byte. That means 4 byte means 32 bits. So 32 bits like can be 100100001. This is 4 bytes. 1 byte, I mean. Then it can be 111100001. Let me form this. This is like the 32 bits. This may be one of the address. Okay. So in order to make it easier to read, we have like dotted notation. Dotted notation. What do you mean by the dotted notation? In dotted notation, what we have is after each byte, we put a dot. After each byte, we put a dot. For example, here we put a dot, here we put a dot, here we put a dot. This is what is known as the dotted notation. So if we convert this into decimal, like this could be like say something like I don't know what actual the decimal conversion would be, but let us assume that it is 192.201.202.29. For example, let's say this. So this is how the addressing is done. Logical addressing is done. Okay. So now with the total 32 bits, in totality, we are having how many bits? 32 bits. So with 32 bits, total number of possible combination would be like 2 raised to the power 32. Okay, that would be the total addresses. So now we have to categorize these 2 raised to the power 30 addresses into some classes so that we could easily assign classes like to different purposes and different applications. For example, if randomly we are going to allot the addresses to any devices, that would create a mess. So in classful addressing, what we do, we divide the entire available addresses into classes. And there are actually 5 classes in classful addressing. And each class is represented as class A, class B, class C, class D, and class E. C. Now these are the 5 classes. What we are actually doing, we are actually having, say, suppose this range of addresses. These are our 2 raised to the power 32 addresses. So what we want to do, we want to categorize these addresses into 5 classes. Why? So that we could use it in such a manner so that it could be as some special addresses could be used for special purposes or general addresses could be used for general purposes. And we should also keep a track of which class of address is utilized, which class of address belong to which source of network, so that easily administration could be done. Okay. For that purpose, we have divided the addresses into 5 classes. That is under the classful addressing. And we know that what is dotted notation? This is the dot notation of addressing. Now, the first byte, that is from if you talk from the MSB, the first byte can be used to identify the address belong to which class. Okay. So also, before we go into that, let us understand that in each address, let us understand over here only that this is the total 32 bit address. So इस एड्रेस में हमारे पास क्या हो सकता है? देखो नेटवर्क्स के अंदर क्या होगा? वी हैव ऑलरेडी सीन दैट दैट कुड बी इंटरनेट के अंदर क्या होता है? वी हैव सीन दैट इन इंटरनेट there are large number of networks which are connected with one another. This is one network. There could be another network. Okay, internet. First, remember the second video in which we have talked about why we need the computer network. उसमें हमने बात की थी इंटरनेट की. तो इंटरनेट what is internet? Interconnection of the network. So like say suppose we have 3 networks. This is network number 1, network number 2, network number 3, and each network is having some devices. Okay. So first of all we need to identify, for example मैं जैसे बोलूं कि this is D1 device D1 and this is device P1. So first of all we have to understand कि device D1 और P1 कौन से network पे है. Randomly तो हम ऐसे नहीं कर सकते कि कहीं भी खोजेंगे. तो we have to find that D1 and P1 is belonging to which network, for which network का भी एक address होना चाहिए. So first we will go to that network address and then in that we will see that कि कौन सा डिवाइस है इन दैट नेटवर्क. फॉर एग्जांपल जब हमने रियल वर्ल्ड एनालॉजी किया था उसमें हमने बताया था कि अगर हॉस्टल ए है और उसके अंदर 6 कमरेज हैं मतलब 6 रूम है तो A1 A2 A3 है. दैट मीन्स कि एक एड्रेस अगर मैं A3 बोलता हूं तो इसका मतलब ये हुआ कि दिस इज बिलोंगिंग टू हॉस्टल ए एंड इन दैट वी आर सर्चिंग फॉर रूम नंबर A3. सिमिलरली जब आईपी एड्रेसिंग करेंगे तो इसमें भी हमें इन द बिगिनिंग वी हैव टू रिप्रेजेंट सम बिट्स टू डोनेट द नेटवर्क, to denote the network. Okay, some bits we will use for the network id and that is called the network id, ताकि हमें ये पता चल जाए कि ओके ये नेटवर्क आईडी कौन सी है, दिस वन और दिस वन और दिस वन, एंड देन इन दैट नेटवर्क आईडी वी विल गो एंड फाइंड व्हाट डिवाइसेस वी आर लुकिंग फॉर. सो द रिमेनिंग गुड बिट्स कुड बी यूज्ड फॉर द डिवाइस इन द नेटवर्क in the similar fashion. For example, A3, that means room number A. So this can be represented as A, where I means that network A in that third device I am looking for. Similarly, in the IP addresses, we can actually use some bits to represent what? The network ID, and the remaining bits we can use to represent the device ID. Okay, if this is clear, so how many bits we are going to use to represent the networks and how many bits we are going to use to represent the device will actually depend upon the class. So for class A, we are going to use the first 8 bits or 1 byte. That is the entire this bits we will use the network ID. So if we say that 129.201.202.29 and I'm saying that this is a class A address, so you will immediately recognize that the network ID is how much? 129. And the remaining is what? The device ID. Correct? So 1 byte for class A, the one entire byte is we are using for what? The entire byte we are using for network ID. In class B, we go on increasing the number of bytes. We use 2 bytes. In class C, we are using 3 bytes. Okay, just remember for class 1, class B, and class C, 3 bytes. That means the first entire byte if we are using to represent the network ID, that is class A. First 2 bytes if we are using class B. If we are using first 3 bytes for the network ID representation, that it is class C. Now, if you are now cleared with why do we need the network ID and why do we need to have a separate device ID inside the IP addresses, then let us move forward for the further representation. So now, from this particular IP address, we should have some mechanism to distinguish between the class A, class B, class C, class D, and class C E addresses so that we can say that this particular range of addresses is class A addresses. So that could be done by taking the first byte. For example, the first byte MSB, what we have here? We have like here 0100100001. This is the first byte that I have copied from here. Okay. So this first byte will range from where to where? The first byte will range from all zeros to all one. Yes or no? Is there any doubt in it? The first 8 bytes, for example, if we have 2 bits, so it will range from 00 to 11. Similarly, we have 8 bits for the first byte. It will range from all 0 to all 1. That means this is ranging from 0 to how much? 2 raised to the power 8. That is 256. Correct? So in class A address, what we do? We reserve the MSB as 0. We reserve the MSB as 0. Okay. In class B addresses, we reserve the first 2 bit like 1 and 0. 1 and 0. Correct? In class C, we reserve the first 3 bit as 110. In class D, the first 4 bit as 110 and class E as 1111. So if any IP address is starting with 1111, we will immediately say that this is what? Class E address. If the MSB is like 0, then 11, so we will say that this is what? Class A address. If we have 10, then we will say that it is class B address. So looking at the MSB bits, we will say whether it is a class 1 address, class A address, class B address, class C or class D, class A address. Okay. So if that is understood, now let us say that if we are using the first byte to distinguish between the class A, class B, class C address, for example, like this address, for example, I'm writing over here 129.201.202.29. So looking at the first byte, if we can say class A, class B, class C, or class D, or class E, which class it belongs to, that would be very helpful for us. So let us say, and we are reserving these bits of the first byte only. That means if the first byte 0 bit is reserved, how many bits we are left with in class A address? We are left with 7 bytes. Okay, with 7 bits, not byte, 7 bits. With 7 bits, we can represent like from 0 up to 2 raised to the power 7. That is how many, what are the maximum number of address that we can use? So we can use up to 2 raised to the power 7 with 7 bits. So 2 raised to the power 7 is nothing but how much? 128. So there could be 128 different addresses, unique addresses of the first byte that could be created with 7 bits. So it means that the first, in a class A address where the first bit is fixed to 0, we will have from 0 to 127. Are you understanding what I mean to say? देखो, लेट मी एक्सप्लेन इन हिंदी. पहला बाइट की अगर हम पहला बाइट के फर्स्ट एमएसबी बिट को अगर हम 0 फिक्स कर देते तो हमारे पास 7 बिट्स बच गया हमारे पास. इस 7 बिट से हम कितने एड्रेसेस लिख सकते हैं पहले बाइट के लिए? ओनली पहले बाइट के लिए, तो बाकी के ये तीनों बाइट छोड़ दो. पहले बाइट के लिए हम कितने लिख सकते हैं? अप टू 2 रेज़ टू द पावर 7. मतलब कि अगर 0 फिक्स कर देते हैं हम पहले बिट को, तो रिमेनिंग बिट्स कहां से कहां तक हो सकता है? 0 से 127 तक हो सकता है, सॉरी 128 तक हो सकता है. कब 128 कब होगा? जब ऑल बिट 1111 होगा. तो ये बेसिकली रिप्रेजेंट करेगा 127. यानी कि 0 से 127 तक टोटल 128 कर सकते हैं, हम लिख सकते हैं. तो इसका मतलब ये हो गया कि अगर किसी एड्रेस का पहला बाइट यानी कि दिस वन 0 से 127 0 से 127 के बीच में लाई करता है, तो मैं इसको क्या कह सकते हैं? क्लास ए एड्रेस कह सकते हैं. करेक्ट. फॉर एग्जांपल ये वाला 129, देखो 129 है, इट इज नॉट अंडर क्लास ए एड्रेस. इफ इट इज 121, देन वी से दैट दिस इज द क्लास ए एड्रेस. ओके. तो पहला बाइट जो होगा क्लास ए एड्रेस का वो होगा 0 से 127 के रेंज में. कम टू द सेकंड क्लास बी. क्लास बी में हमारा 2 बिट्स हमको रिजर्व कर रहे हैं 10. तो अगर हम 2 बिट्स रिजर्व कर रहे हैं तो वी आर लेफ्ट विथ हाउ मेनी बिट्स इन द फर्स्ट बाइट? 6 बिट. 2 रेज़ टू द पावर 6 इज हाउ मच? इट इज 64. So we can represent 64 different addresses with first byte. So 0 से 127, here we are having 0 से 127. Add 64 to it. Add 64 to it. How much we are getting? 192. That means if we include 128 over here, we will be left with 191. So if the first byte is like 128 to 191 के range के अंदर, we will say it is class B address. Similarly, first 3 bit is reserved. So we are left with 5 bits. 2 raised to the power 5 is 32. If we add 32, how much we will get? 4, 9, 3 is 12, 224. So from 192 say 223, this will like be 192 say 223 will be class C. For here we are reserved with 4. We are reserving 4 bits. So if we are reserving 4 bits, so we are left with how many? 4. 2 raised to the power 4 is nothing but 16. So you add 16 to 224. It will how much? 6, 4, 10, 2, 1, 3, 4, 2. So if you include 224 from here, you include this one from here. So you will have the minus 1 from here. So it is 239. So 224 say 239 will fall under the range of class D. Similarly, this is also 4. That is 2 raised to the power 4. Add 16. It will write 256. So 240 say 255. If you are including 240 over here, so this will be minus 1, 255. So this range, we will say that it is class A address. Now, for example, if I say to you, for example, if I say to you that 223.126.212.41 belongs to which class address, you'll just have to look at the first byte. It is 223. Look at where it is falling on. It is falling into class C. 192 say 223. You will say that it is class C address. This is how we can distinguish. If it is 121, you will say that 121, the first byte is falling under class A, so it is a class A address. Is it clear? How we identify class A, class B, class C, class D, class C address? Now, if that is clear, let us move further. We have already seen that in class A, we represent the network ID with 1 byte. So 1 byte means 8 bits. So how many networks? How many network ID? That will be 2 raised to the power 7. Why 7? Because although we are using 1 byte, but actually we are fixing 1 bit. We are fixing 1 bit over here. So why 2 raised to the power 7? Because although we have 8 bits, but 1 bits तो हमारा रिजर्व है. किस लिए रिजर्व किया हमने? डिफरेंशिएट करने के लिए डिफरेंट क्लासेस को. तो हमारे पास ओनली 2 raised to the power 7 ही बचता है. ओके. सिमिलरली नेटवर्क, हमारे पास कितने नेटवर्क्स आईडी हम रिप्रेजेंट कर सकते हैं? 2 raised to the power 7. और होस्ट का मतलब है कि कितने डिवाइसेस उससे हम कनेक्ट कर सकते हैं उस नेटवर्क आईडी के अंदर? सो हमारे पास कितने बिट लेफ्ट, वी आर लेफ्ट विथ हाउ मेनी बिट्स, कितने बिट्स हमारे पास बच गए हैं? अगर हम 1 बाइट को रिजर्व करना नेटवर्क आईडी के लिए, तो हमारे पास ऑब्वियसली ये रिमेनिंग बिट्स बच गए हैं, यानी कि 32 बिट्स में से 8 बिट्स वी हैव रिजर्व, सो वी आर लेफ्ट विथ 24 बिट्स. सो इन क्लास सो इन क्लास ए नेटवर्क आईडीज के लिए हमारे पास 2 to the power 7, और होस्ट के लिए हमारे पास कितना है? 2 to the power 24. ओके, out of which there are two special addresses, all bits zeros and all bits one. If all bits are zero, that means it is broadcast. If all bits are one, it is also reserved for loopback. So broadcast can be two type. Limited broadcast, one is called the limited, other could be direct. Let us clear this out at this point only. लिमिटेड ब्रॉडकास्ट का मतलब ये है कि सेम नेटवर्क के अंदर ही हम, ब्रॉडकास्ट मतलब क्या होता है कि हम सबको ही भेज रहे हैं, ऑल द होस्ट या ऑल द डिवाइसेस जो भी नेटवर्क के अंदर कनेक्टेड है, सबको वो मैसेज जा रहा है, दैट इज द ब्रॉडकास्ट. लिमिटेड ब्रॉडकास्ट का मतलब होता है कि सेम नेटवर्क के अंदर. डायरेक्ट ब्रॉडकास्ट का मतलब होता है कि इंटायर नेटवर्क, जो भी नेटवर्क है, जितने भी नेटवर्क है और उनके अंदर जितने भी होस्ट हैं, सबको आप ब्रॉडकास्ट करें, दैट इज द डायरेक्ट ब्रॉडकास्ट. ओके, तो अगर हम ये दो एड्रेस माइनस कर देंगे तो डिफरेंट होस्ट, ये दोनों रिजर्व होते हैं फॉर ब्रॉडकास्ट एंड लूप बैक. तो होस्ट के लिए हमारे पास कितने एड्रेसेस बच जाते हैं? 2 to the power 24 माइनस. सो क्लास ए में हमारे पास नेटवर्क आईडीज के लिए वी हैव 2 to the power 7, एंड होस्ट के लिए वी हैव 2 to the power 24 माइनस 2. Similarly, if we move on to class B, so for class B, we are using how many bytes? 2 bytes. For in 2 bytes, like how many 2 bytes means 32 16 bits. But here we have reserved 2 bits, 1 and 0. So we are left with, actually we are left with 14 bits. So different addresses, यानी कि network IDs that are possible is 2 to the power 14. And host, how many host? होस्ट के लिए अगर 2 बाइट्स हम रिजर्व कर दे रहे हैं क्लास को, नेटवर्क आईडी को रिप्रेजेंट करने के लिए, तो होस्ट के लिए हमारे पास 2 बाइट्स बच जा रहा है, यानी कि 16 बिट्स. तो 2 to the power 16, इसमें से हम 2 माइनस कर देंगे, तो दिस इज होस्ट. क्लास बी में टोटल नेटवर्क आईडीज दैट इज पॉसिबल 2 to the power 14, होस्ट इज 2 to the power 16. क्लास सी की बात करें अगर, तो क्लास सी में हमारे पास 3 बाइट का नेटवर्क आईडी होता है, यानी कि 8 3 द 24 बिट्स. तो हमारे पास कितने नेटवर्क आईडीज पॉसिबल हो सकते हैं? 2 to the power 24 में से क्लास सी के अंदर 3 बिट्स को हम रिजर्व कर लेते हैं, 1 1 0, दिस इज रिजर्व. तो हम 2 to the power 24 में से 3 गया 21, 21 इतने डिफरेंट नेटवर्क आईडीज को हम रिप्रेजेंट कर सकते हैं, और कितने होस्ट को कनेक्ट कर सकते हैं हम? दैट इज कितना लेफ्ट हो गया? 2 to the power 8, 2 to the power 8 minus 2. Okay, this is network IDs and this is host. Similarly, this is for class C. Similarly for class D and E, हमारे पास तो बेसिकली क्या है, टोटल एड्रेसेस कितने हैं हमारे पास? 28 बिट्स. देयर इज नो नेटवर्क एंड होस्ट सेपरेशन इन इट. तो 4 bits are reserved. If 4 bits are reserved out of 32 bits, how much left? 28. So total addresses possible in the class D and E are 2 to the power 28. There is no separation of network ID and host IDs in the class D and E. So there is no bytes reserved for the network ID or host ID. So class D is reserved for future use. Class C addresses is reserved for future use, and class D is for multicast address. It is used for multicast address. Just remember this. So I hope now it is clear what is the different classes and what do we have, like the how many network IDs and host ID. That could be one of the most potential questions to come. So you have to remember this. Now see, so now let us understand what is subnet mask. Subnet mask. Okay. So before we understand what is subnet mask, let us understand what is subnet. Subnet is basically is what we call as the subnetwork, network within network. So the detail of it we will go in later on. So what is subnetwork? We have understood. Suppose this is a network of devices. So this is a network of devices. So what we do, we create a subnetwork from it. Like we separate these number of devices, we make it one subnetwork. We separate this number of devices, we make it another subnetwork. So one network is divided among two subnetwork, and this technique is known as subnetting. Okay. So before we go into detail of subnetting, let us understand what is subnet mask, or what is basically mask address. For example, recently we have seen that if I write at 192.221.14.6, so just looking at this, you can represent that this belong to class A, class B, or class C. So from here you will say that it is belonging to class C, 192 belonging to class C. Okay. So now if I say this is belonging to class C, correct? There is no confusion in that. Now, if I say that what is the network ID and what is the host ID, how will you differentiate? What is the network ID and what is the host ID? So you will say, sir, in class C, we have 3 bytes that represents the network ID. So these 3 bytes are basically the network ID, 192.21.14, and the remaining byte will represent the host ID. So 6 represent the host ID. Okay, very correct. There could be another technique that could be used to identify this network ID and the host ID. And that is technique is known as the mask. So for this, what do you mean by mask? What is actually mask is? So a mask is nothing but a series of ones followed by zero, where the number of bits that are one represents the network ID and the number of bits that are zero will represent the host ID. This is what mask is. So if I say that for class C, these 3 bits represent the network ID. So can I say for the class C, the mask would be like 1 1 1 1 1 1 1 1 8 times once, then again 8 times once, then again 8 times once, then again followed by 8 times zero. This would be the mask for class C address. Why? Because we have seen that the mask basically represents what? Network ID. So network ID are first 3 bytes are the network ID. So अगर पहले के 3 बाइट नेटवर्क आईडी है और अगर हम इसका मास्क रिप्रेजेंट करना चाहते हैं तो इट विल बी रिप्रेजेंटेड बाय ऑल वन. So this is nothing but 255. This is also 255. This is also 255 and this is 0. So the class C का मास्क क्या हो गया? 255.255.255.0. Similarly, क्लास ए का अगर मास्क लिखेंगे तो क्लास ए का मास्क हो जाएगा 255. ओनली फर्स्ट बाइट जो है वो नेटवर्क आईडी रिप्रेजेंट करता है .0.0.0. क्लास बी का 255.255, यहाँ पे 2 बाइट्स होते हैं हमारा, यहाँ 1 बाइट होता है नेटवर्क आईडी, यहाँ 2 बाइट्स नेटवर्क आईडी होता है .0.0. और क्लास सी का 3 बाइट होता है. क्लास सी 3 बाइट्स होता है. तो we can also identify the classes of address if we know the mask of it. For this, it is very simple. You say, why we sir mask की जरूरत ही क्या है? अगर क्लास ए, क्लास बी, क्लास सी हमारा एड्रेस है, तो हमें मास्क की जरूरत क्या है? यहाँ तो मास्क का कोई वैल्यू ही नहीं है, क्योंकि हम पहला बाइट ही देख करके बता देंगे कि ये क्लास ए है, क्लास बी है या क्लास सी है. और हमें पता है कि क्लास सी में प्री डिफाइंड है 3 बाइट, 2 बाइट, 1 बाइट. तो ऑब्वियसली हमें पता है कि यहाँ पर क्लास सी के अंदर ये 3 बाइट्स जो है ये हमारा नेटवर्क आईडी है. तो हमें मास्क की जरूरत क्या है नेटवर्क आईडी निकालने के लिए? तो बेसिकली देखो, इसीलिए हम यहाँ पर व्हाट टर्म वी आर यूजिंग, सब नेट मास्क. If there is a perfect division of the network, that is, it is divided into class A, class B, class C, then without mask you will be able to clearly say कि class A address है, class B address है या class C address है. लेकिन सब net mask का मतलब होता है कि when there is a network within the network, in that case it will be difficult to say what is the network ID and what is the host ID, and for that purpose we are using mask where all ones represent the network ID and all zero represent the host ID. Let me make this a little more clear for you. फॉर एग्जाम्पल से क्लास सी की अगर हम बात करें, फॉर एग्जाम्पल क्लास सी एड्रेसिंग, तो इसमें वन एग्जाम्पल इज लाइक 200.1.2.0. दिस कुड बी वन ऑफ द एड्रेस ऑफ द क्लास सी, वेयर 200 इज व्हाट, 200 is representing what, it is falling into class C range. You can check from here, the range is 192 to 223, so 200 falls under that class C category. So the first 3 bytes will be representing what, it will represent the network ID. So this is the network ID. Okay sir, that is clear. So we have already known that class C ka mask will be 255.255.255.0. Okay sir, that is clear. Now let me make a diagram and explain it to you. So if I say let each dot represents a device. This is a single network. I'm not going into inter-network. This is a single network. Okay. And this network, suppose this is a network. These all dots are device. So suppose this network is having a network ID as 200.1.2. There could be similarly और भी बहुत सारे नेटवर्क होंगे जिनका नेटवर्क आईडी होगा 200.1 डॉट समथिंग एल्स। लेकिन स्पेसिफिकली अगर हम इस नेटवर्क की बात करें तो इस नेटवर्क का नेटवर्क आईडी क्या है, 200.1.2। ओके, इस नेटवर्क आईडी से हम इस नेटवर्क तक पहुंच गए। अब इसके अंदर हम आएंगे तो इस डिवाइस का अगर हम मान लो आईपी एड्रेस निकालते हैं या एड्रेसिंग करते हैं तो 200.1.2 डॉट इसको मैं बोल देता हूँ 1, यानी कि पहला डिवाइस है ये इस नेटवर्क के अंदर। सिमिलरली हम इसको बाकी 128 डिवाइस इसके अंदर हम मैक्सिमम यूज कर सकते हैं क्लास बी के अंदर। क्लास बी के अंदर हमारे पास कितने होस्ट है टोटल, देखो हाउ मेनी होस्ट वी कैन एड्रेस इन क्लास सी। In class C, we can address 2 raised to the power 8 minus 2. So 2 raised to the power 8 is how much? 256 minus 2 is how much? 254. So total 254 different होस्ट को हम यहाँ पर एड्रेस कर सकते हैं। तो मैक्सिमम हम 254 डिवाइस को कनेक्ट कर सकते हैं इस नेटवर्क के अंदर। लेकिन ये नेटवर्क इतना बड़ा है 254 डिवाइसेस का कि इसका एडमिनिस्ट्रेशन बहुत डिफिकल्ट है। फॉर एग्जांपल यहाँ पर कोई डिवाइस है, इसको हमको आइडेंटिफाई करना है या एडमिनिस्टर करना है, दैट इज वेरी डिफिकल्ट। टू मेक इट मोर इजियर टू एडमिनिस्टर वी हैव वन ऑप्शन, दैट इज हम इसको सब दूसरे ग्रुप्स ऑफ इसको ग्रुपिंग कर देंगे डिफरेंट डिफरेंट डिवाइस को। इसको वी कैन मेक ग्रुप्स ऑफ डिवाइसेस एंड वी कॉल द नेटवर्क्स, वी कॉल देम नेटवर्क्स। तो यहाँ हमने 4 ग्रुप्स बना लिए। ओके, डिफरेंट डिवाइसेस को 4 ग्रुप्स बना लिए। अब हर ग्रुप्स के अंदर वी हैव लिमिटेड नंबर ऑफ डिवाइस, सो वी कैन इजीली मॉनिटर ईच डिवाइस। ओके, हर ग्रुप के अंदर वी हैव लिमिटेड नंबर ऑफ डिवाइस और इस ग्रुप को हम नेटवर्क नहीं बोल सकते बिकॉज इट इज ऑलरेडी अ नेटवर्क एट द आउटर। सो दिस कैन बी कॉल्ड एज सब नेटवर्क, दैट इज नेटवर्क बिटवीन सब नेटवर्क, और इन शॉर्ट वी कैन कॉल इट सबनेट। ओके, सबनेट। नाउ वी हैव टू लाइक नेटवर्क के लिए तो हमें एक एड्रेस मिल गया ऑब्वियसली 200.1.2। अब हमें इन 4 जो सब नेटवर्क बनाया है हमने इनको 1 2 3 एंड 4, इन 4 सब नेटवर्क को भी एड्रेस करना पड़ेगा। तो उसके लिए हम क्या कर सकते हैं, दैट इज व्हाई वी कैन डू, यहाँ पर हमारे पास क्या है 200.1.2। वी कैन नॉट चेंज दिस बिकॉज दिस रिप्रेजेंट द क्लास सी एड्रेस। व्हाट वी आर लेफ्ट विथ, वी आर लेफ्ट विथ 8, दिस इज 8 बिट्स व्हिच वी आर यूजिंग टू रिप्रेजेंट डिफरेंट डिवाइसेस। तो अब हम इसको रिप्रेजेंट कर सकते हैं लाइक फोर नेटवर्क के लिए हमें कितने बिट्स चाहिए, 2 बिट्स। तो हम इस 2 बिट्स को रिजर्व कर लेंगे। ओके, तो इस 2 बिट्स को रिजर्व करने के बाद हमारे पास कितने बिट्स बच जाएंगे, 6 बिट्स, 2 raised to the power 6, दैट मींस 64। तो अब हर नेटवर्क के अंदर हम 64 मैक्सिमम डिवाइस को रिप्रेजेंट कर सकते हैं। लेट्स से यहाँ पर हमारा कितना है 4 डिवाइस, यहाँ पर 6 डिवाइस, यहाँ पर 8 डिवाइस और यहाँ पर 10 डिवाइस, तो इजिली हम रिप्रेजेंट कर सकते हैं। ओके, सो यहां तक आपको क्लियर है, कोई डाउट नहीं है। सो अब हमने क्या किया, टू रिप्रेजेंट दिस 4 सब नेटवर्क वी हैव फिक्स्ड 2 बिट्स। सो नाउ दिस 2 बिट्स वुड बी लाइक, let this be same as 200.1.2 would be like 01, would be like 00, first one is this, second is 01, then 11 and 10, this could be third, this could be fourth. So now this was the outer network and now this is acting as the sub network. What was the mask of this? The mask of this was 255.255.255. Now from here we may have different devices, say 0, 1, 2, 3, 4, whatever devices we may want to connect in each network. From here it will range from 0000000 say 1111111. Okay, and this will be 00 itself. Now from here it will range from 01000 say 11111. So if we convert into decimal, this will range from 0 to how much? 0 to 63. This will range from what? This will not 63, but it will range from 64 to like 1111, how much? 125 or whatever the conversion is. Okay. So now हमारे पास 4 सब नेटवर्क्स हो गए। अब now if I give you this address, for example this address 200.1.2.10, और इसके आगे जो है हमारे पास रेंज ऐसे हो सकते हैं 00000 से 1। सो दिस इज व्हाट 10000001 and this is equivalent to how much? This is 2 raised to the power 7, that is 120, 126, 64 into 2, 128, sorry, 128, and this is 129. So if this is the address 2.1.2.129, now how will you identify what was the network ID? See, from the class you can say that, sir, this is a class C addressing. Okay, so class C will have 255, 255, 255, or these 3 bits represent the network. But there is a sub network. Now how will you identify the sub network? So for that we will use subnet mask. The subnet mask of this will be obviously all this will be 111, and we have 2 bit that is representing the sub network. So for these 2 bit we will take 2 ones. Because in sub-network, we have seen number of ones represent what? Number of ones represent the network ID. So to represent the sub-network ID, there are how many bits are reserved for sub-network ID? 2. So the mask of this would be like 255.255.255.11, then all zeros. Because these 2 bits in this classification is reserved for what? Sub-network. So 2 ones and remaining is 0. So this is nothing but 2 raised to the power 7 plus 2 raised to the power 6. Whatever you will get, this is the mask. Okay. So if any mask is given, you can easily calculate the network ID or sub-network ID. I hope this is clear. Why? What is subnet? What is subnet mask? What is mask? Basically, mask comprises of number of ones and a number of zeros. When number of ones represent the network ID or the sub-network ID, including the network ID. So if that is clear, this is actually what we have the logical addressing, and this is the different addresses like IP addresses. Okay. So there could be another notation which is known as the classless inter-domain CIDR routing notation. And this is this what above we have done was the classful addressing, and there another could be the classless addressing. So in classless addressing, we represent it as CIDR notation, classless inter-domain routing notation. With classless inter-domain routing addressing, we do it addressing like this, like x dot y dot z dot k slash n, where this is the same as the IP address, and this n represent the number of bits in mask, that is 1, जो 1 के बराबर. Okay. So if we say that for class A को अगर हमको represent करना होगा, तो we say that इसका क्या होगा? For example, 12.24.76.8. If this is the IP address, the mask is of how many bit? 8 bit. For class B, like so suppose we are having 220.8.24.255, and we say that it is 25. So the 25 itself represent that this is a subnetwork. This is subnet IP address. Why subnet? See, 8-bit, 16-bit, and 24 bits, where 8-bit mask is of class A, 16-bit mask is of class B, and 24-bit mask is of class C. Apart from that, if we have 25, that means we are using 1 bit extra to divide the network into 2 parts. One will be given 0, another would be given 1. So this is the subnetting, and the number of bits that is used for mask is 25. So this is how CIDR notation works. So we have completed here the datagram of IP. We have seen the packet with the total number of fields and the total length of the packet. Then we have seen the different classes of address. So this is all with this lecture. In the next video, we will talk about the different protocols of the network layers. Thank you.